Hello everyone. In this video, we'll be dealing with the question reverse nodes in K group. This is labeled as a hard question, but honestly, it is just a mixture of two relatively simpler problems. The first of which is reversing a linked list. The second of which is swap nodes in pairs, which is what we solved in the previous video. So if you've gone through that, you'll probably get a better idea of how to solve this one. If you haven't, I suggest that you do so. It will build intuition that will help you solve this one and other linked list questions. As of now, we'll deal with this one that we have in front of us, in which we've been given the head of a linked list and we have to reverse the nodes of that list k at a time. So let's say if k is equal to 2, we have to take groups of 2, reverse each group separately, and return the head of this newly formed linked list. Alright, so if k is equal to 2, this will get reversed somewhat like this. Keep going forward, keep repeating the process. If you have a group that does not have k number of elements in it, you keep that group as it is and then return the head of the linked list. The question seems simple enough. So let's get to how we're going to now solve it. We have this list over here, this 5 points to nothing. We are going to start off very simple. We will get us a dummy node, which will point to the head. This dummy node, if you've noticed in other linked list questions, just helps us handle certain edge cases where, let's say, we don't get an input, it's an empty input, or if we have one node only. Dummy node usually helps us resolve these cases with ease as compared to just handling the cases manually. But of course, you're free to do so. It will give you a better idea on how to handle edge cases. For now, we're sticking to this approach. Now we have this dummy node, which I'm going to place a variable on. This will represent the previous node, the previous group's last node. All right, don't get confused with what I just said. We have groups over here, right? This particular variable will track the last group's last node. So let's say if we are dealing with this group right here, this previous will be somewhere over here. Track the last node of the previous group. All right, that is basically all that we're doing with this variable. I'll move it back to the dummy node for now. Then we have this other variable that I want to keep, which is what I will keep over here. This will be our current node. It will keep on moving forward and usually represent the head of the group that we're supposed to deal with. All right. So let's keep this over here. Now, we have to do certain things. Number one, we have to keep moving forward till this current node reaches the very end. That is when this entire linked list will be considered processed. All right. Next, in each such iteration where we are processing each of the groups one at a time, we will have to perform a check. We will check whether this current group that we're testing is complete or not. Next, what we're going to do is, if our group is complete, we will reverse its nodes and return the head, and we will attach it to the previous group. But if our group is not complete, we will simply keep it as it is. Lastly, we will simply return whatever comes after this dummy node. All right. So that is the basic algorithm. Let's do a quick dry run to understand how this actually works in action. So we will keep on going till current reaches the end of the list. What does that mean exactly? Inside this particular while loop, this point number 1 will represent a major while loop. Inside that, we will check if the group is complete or not. How do we check if a group is complete? That is a very important question for us right now. We will keep a counter with us. So let's keep the counter over here. All right, for every group, this counter will reset and start from 0. Here we have this current variable. This current variable will keep on going till this current reaches the null value. So before that, we'll keep on going, or till our counter becomes equal to k. So as long as this counter is less than k, we're good. We can keep moving this current variable forward. Okay. So let's do that for point number 2. This is more of a stop-in condition, point number 1. So point number 2 is where we start our process. All right. So we have this current. We move this once. Our counter gets updated to 1. We go again. We check if this current has reached null or not. It has not. What about our counter? Is it equal to k? It is not. So we can move it forward one more time and update our counter. Now, while current is not equal to null, but counter is actually equal to k, so we get out of this condition. It is not less than k anymore. After that, we have to check if our group is complete or not. How do we check if our group is complete? If this counter is equal to k, that means our group is complete. It has exactly k elements in it. So the group basically can be reversed. And is that the case for us right now? The answer is true because k is 2, counter is also 2. So we reverse this group's nodes, which I will just write separately for now. So we have our dummy node, let's say. I'm just forming the answer node over here. This dummy node, this group will get reversed. So that will become 2 followed by 1. And then we will, what we'll do is reverse this group's nodes and attach it, like I've mentioned, to the previous group. Now this is represented by this previous variable. So previous dot next gives us something like this particular linked list so far. Then we go and check again, is current at the end of the list? It is not. So we repeat this process. Is our group complete when we are over here? Of course, this counter has now reset back to 0. Is our group complete? Let's see. We move this forward. Counter will become 1. We move this forward again. Counter will become 2. We have reached this particular condition again. We get out of this point number 2. This counter has fulfilled its purpose for this iteration. The group is complete because k is 2, counter is 2. So we again repeat the process. We reverse this group, and that will again be implemented in the next video. So stick around for that. For now, I'll just write down what it would look like after the process is done. 4 will be followed by 3. Then we have our current variable once again. Has current reached the end of the list? It has not. It will reach the end of the list after no more nodes are left to process. We still have this 5 to process, right? Is our group complete? Let's see for ourselves. This current moves over here. This cross that I've made over here, in case it is not very legible to you. This current has moved over here. The counter was reset, but after moving it over here, it is now 1. Is current now null? It actually is. So we go and check if our group is complete. How did we check if our group is complete or not? Was counter equal to k? In this case, it is not, because 1 is not equal to 2, right? So we will simply keep it as it is and attach it to the previous group. Now the point that I missed for now is that whenever I restarted the process, I did not update this previous value. So when I was done with this reversal 2 and 1, I should have moved this previous over here. All right. And then what would have happened next was that when 3 and 4 would have been reversed, the next value of this previous would have been 4 followed by 3. After which I would have updated this previous variable over here. So right now, since we're keeping it as it is, we will return this node over here that will give us 5 at the end of this list. All right, which will go a little down because I don't have much space. After that is done, our linked list is formed. We will return the node after dummy over here. So dummy reference was kept as it is, the root node, the dummy node. The node that came after that was 2. That is what we will return as our answer. And let's just compare and see if that is what we have. So we have 2, 1, 4, 3 followed by 5. And that is exactly what we have over here. And that is what we are supposed to do for this particular question. In the next video, we will be implementing this. So stick around and just follow for more.